In 541 AD, the Roman Empire was on the verge of reclaiming its former glory. Constantinople was the largest city on earth. Emperor Justinian had reconquered North Africa, retaken Italy, and was rebuilding the empire that Rome had lost. Then the ships from Egypt arrived. Justinian's ambition was total restoration. His generals had crushed the Vandals in Africa and the Ostrogoths in Italy. The Mediterranean was becoming a Roman lake again. Within weeks, the dead were piling up faster than the living could bury them. Bodies filled the streets. Mass graves overflowed into the sea. The historian Procopius wrote that at its peak, 10,000 people were dying every day in the capital alone. Towers and fortifications were filled with corpses when the graves ran out. Ships loaded with the dead were sent out to sea and left to drift. It became known as the Plague of Justinian, and historians have debated its cause for 1,500 years. Some argued it was smallpox, others said typhus or influenza, or something that no longer exists. For decades, the identity of the pathogen was one of the great unsolved questions in medical history. The symptoms described by ancient writers, swollen lymph nodes in the groin and armpits, fever, delirium, and rapid death, sounded like bubonic plague. But without physical evidence, it remained speculation. Each competing diagnosis had its defenders. The debate filled academic journals for decades. Only the pathogen's own DNA could settle it. Then, scientists tested the teeth, and the answer rewrote the history of pandemics. In 2013, a team of researchers extracted ancient DNA from the dental pulp of victims, buried in a 6th century cemetery in Bavaria, Germany. Dental pulp is a gold mine for ancient pathogen DNA. When bacteria flood the bloodstream during infection, they become trapped in the tooth's inner chamber, sealed from the environment for centuries. The dental pulp contained DNA from Yersinia pestis, the bacterium that causes bubonic plague, the same pathogen that caused the Black Death 800 years later. Not a related organism, not a cousin. The same species, Yersinia pestis, separated by 8 centuries but connected by an identical mechanism of death. But the real surprise wasn't that it was plague. It was that the two strains weren't closely related at all. The first piece of evidence was the genome itself. When researchers assembled the full sequence of the Justinianic plague bacterium, it sat on a completely different branch of the Yersinia pestis family tree. The Black Death strain belongs to a lineage called Branch 1. The Justinianic strain belongs to a much older, now extinct lineage that diverged thousands of years earlier. This meant the two worst plagues in European history were caused by the same species, but different strains that had evolved independently in separate animal reservoirs, possibly on different continents. The genomes shared roughly 97% of their DNA, but the 3% that differed included genes controlling how the bacterium interacted with its hosts. Yersinia pestis itself evolved from a relatively harmless soil bacterium called Yersinia pseudotuberculosis, roughly 5,000 to 10,000 years ago. The transformation required fewer than 100 key mutations. A handful of gene acquisitions turned a stomach bug into a mass killer. A handful of genetic mutations transformed it from a gut pathogen into one of the most lethal organisms in history. The ability to colonize flea guts, the ability to suppress the immune system, the ability to spread through the lymphatic system. And both strains shared those critical mutations. Both could infect fleas. Both could jump from rodents to humans. Both could kill within days. The second piece of evidence came from where the teeth were found, not in Constantinople, but in a small cemetery in Aschheim, a village in southern Bavaria. The Bavarian victims died at the far western edge of the Justinianic plague's reach. By the time the disease reached Central Europe, it had already devastated the eastern Mediterranean. The cemetery at Aschheim contained burials consistent with epidemic mortality. Multiple individuals interred simultaneously without standard Merovingian-era grave goods. The dead weren't buried with the care typical of 6th century Bavarian communities. They were buried fast. The plague arrived in Egypt in 541, probably from Central or East Africa via Indian Ocean trade routes. It reached Constantinople within months. From the capital, it spread along the empire's trade networks, reaching every port city in the Mediterranean within 2 years. Every port that received Egyptian grain received Egyptian rats, and every rat carried fleas loaded with Yersinia pestis. The grain ships that connected Egypt to Constantinople were the perfect transmission vector. Rats infested the cargo, fleas infested the rats, and Yersinia pestis infested the fleas. Contemporary sources describe mortality rates between 25 and 50% in affected cities. Modern estimates suggest the Justinianic plague killed between 15 and 25 million people across the Mediterranean world. And unlike the Black Death, which struck in a single devastating wave, the Justinianic plague returned again and again for over 200 years. At least 15 to 18 separate outbreaks between 541 and roughly 750 CE. Each wave hitting populations that had barely recovered from the last. The recurring waves may have been more devastating than the initial outbreak. Communities that rebuilt after each epidemic were struck again before they could reach demographic stability. The third piece of evidence connected the plague directly to the fall of the Roman Empire, and this is where the genomics became history. Before the plague, Justinian had reconquered vast territories: Italy, North Africa, southern Spain. The empire was expanding. After the plague, it could barely hold Constantinople. The Roman army couldn't fill its ranks. Tax revenues collapsed because there weren't enough people alive to pay them. The bureaucracy that held the empire together lost the manpower to function. Justinian survived the plague himself, barely. But the empire he'd rebuilt never recovered. Entire provinces depopulated. Cities that had thrived for centuries shrank to villages. The infrastructure of Roman civilization, roads, aqueducts, courts, couldn't function without the people to maintain it. Within a century of the first outbreak, Arab armies swept through the plague-weakened eastern provinces. Syria, Egypt, North Africa, all lost permanently. The world Justinian had rebuilt was gone. The plague didn't just weaken the empire militarily, it shattered the economic base that paid for the army. Depopulated provinces couldn't generate the tax revenue needed to maintain a professional military. But here is the twist. Not everyone agrees the Justinianic plague was as devastating as the ancient sources claim. In 2019, a group of historians published a provocative challenge. They argued the literary sources were exaggerating, that the plague was serious but not civilization ending. Tax records from Egypt showed continued administrative activity during the plague decades. Buildings were still being constructed. Trade continued. Their evidence included pollen records from lake sediments. If agriculture had truly collapsed, the pollen record should show forests reclaiming farmland. In some regions, it didn't. Coin hoards, papyrus tax records, building inscriptions. The material evidence for a catastrophic demographic collapse was thinner than the literary sources suggested. The debate split historians into two camps. One said the plague reshaped civilization. The other said the ancient writers were performing rhetoric, not reporting statistics. And then the geneticists weighed in again, because the DNA could answer something the pollen records couldn't. By 2022, Yersinia pestis had been confirmed in 6th to 8th century burials across an enormous geographic range, from southern France to Germany to Central Asian steppe sites. The pathogen was real, it was everywhere, and it was genetically confirmed in contexts that matched the literary timeline precisely. The burial practices themselves told a story. Individuals buried hastily, without standard funerary rites, in pits rather than proper graves. The signatures of a community overwhelmed by death. In 2021, a team sequenced the complete genome of the Justinianic strain from a burial in Altenerding. Also, in Bavaria, the full genome revealed something remarkable about how the bacterium had evolved. The Justinianic strain carried unique genetic adaptations not found in any modern or Black Death-era strain. 17 unique single nucleotide polymorphisms distinguished the Justinianic genome from all other known Yersinia pestis strains. Some of those unique genes related to how the bacterium evaded the host immune system. Others affected how it colonized flea gut tissue, potentially altering its transmission dynamics. The Justinianic strain wasn't just a different lineage, it was a differently armed pathogen, carrying weapons that the Black Death strain had never developed. Both strains carried the 3 essential Yersinia pestis virulence plasmids, but the genes within those plasmids had diverged significantly, suggesting different evolutionary pressures in their respective animal hosts. And then it vanished. After roughly 750 CE, the Justinianic strain disappears from the archaeological record entirely. No descendant lineages have been found in any modern rodent population. The lineage went extinct. 200 years of recurring devastation, millions of deaths, and then the organism simply disappeared from the face of the earth. The Black Death strain, by contrast, survived. Its descendants still circulate in rodent populations today. Whatever killed the Justinianic lineage spared the lineages that would come after it. Why? Researchers don't know. The rodent reservoir may have collapsed. The surviving human population may have developed sufficient immunity. The ecological conditions that sustained transmission may have changed. And 6 centuries later, from a completely different rodent reservoir in Central Asia, a completely different strain of the same species emerged and began killing again. The Black Death strain, branch 1, diverged from the main Yersinia pestis trunk, roughly in the 13th century, likely in the area around modern Kyrgyzstan. In 2022, researchers identified what may be the very cemetery where the Black Death began, near Lake Issyk, Kul in Kyrgyzstan, where tombstones from the 1330s record deaths from an unspecified pestilence. The tombstones were inscribed in Syriac, recording that the dead had perished from pestilence. The teeth confirmed what the stones described. DNA from those burials confirmed Yersinia pestis, branch 1, the direct ancestor of the strain that would reach Europe in 1347 and kill a third of the continent's population. Buboes in the groin, armpits, and neck, fever, delirium, and death within days. Procopius in 541 described the same symptoms that Boccaccio would describe in 1348. The clinical presentation was identical because the molecular mechanism was identical. Different strains, but the same lethal playbook encoded in the same species genome. 2 pandemics, same species, different strains, different origins, different centuries. Nearly identical outcomes. The Black Death killed roughly 50 million people between 1347 and 1353. The Justinianic plague may have killed a comparable number over its longer, slower burn. Together, they represent the 2 greatest mortality events in recorded human history, both caused by a single bacterial species that evolved from a harmless soil microbe. The Justinianic plague may have delayed global population recovery by centuries. The Roman Mediterranean wouldn't reach pre-plague population levels until the early modern period. The demographic vacuum left by the plague reshaped settlement patterns across Europe and the Middle East. Cities shrank, rural populations disappeared. Entire landscapes were rewilded. So, what does this change? It changes how we understand pandemics themselves. The old assumption was that plague was a single story, one lineage causing one catastrophe after another. The DNA proved it was a repeating pattern. Yersinia pestis didn't attack humanity once and return. It evolved independently in separate reservoirs and attacked multiple times. The Justinianic plague and the Black Death were parallel events, not a single ongoing war. And it happened a third time. In 1894, plague emerged again in Yunnan, China, and spread worldwide via steamship. The third pandemic killed roughly 12 million people, mostly in India. 3 pandemics, 3 separate emergences. One species that keeps finding new ways to reach us. And Yersinia pestis is still out there. It circulates today in rodent populations across Central Asia, parts of Africa, and the American Southwest. Roughly 2,000 human cases are reported worldwide every year. Modern antibiotics make individual plague cases treatable, but the reservoirs persist, and the bacterium continues to evolve. The question isn't whether plague will emerge again. It is whether we'll recognize it when it does. Today, satellite monitoring of rodent die-offs in endemic zones provides early warning of potential outbreaks. The genomes extracted from ancient teeth helped build that surveillance system. By understanding how plague evolved in the past, researchers can predict how it might evolve in the future. The dead are teaching the living how to survive. Ancient teeth from a Bavarian cemetery answered a 1,500-year-old question. The plague that broke the Roman Empire was the same disease that would later break medieval Europe, but it wasn't the same strain. It wasn't the same outbreak. It was the same evolutionary trick performed twice by a microbe that has been adapting to kill us for thousands of years. A single tooth from a Bavarian cemetery held the answer to a question that historians had debated for centuries. The pathogen left its signature in the dental pulp and waited 1,500 years for someone to read it. If you want to see where the evidence leads next, subscribe. We follow the DNA wherever it goes. 1,500 years later, the teeth still hold the answer. The evidence speaks.